Today, we are going to look at finding a missing side. Now, this is different from what we did previously with Pythagorean theorem, because in order to find a missing side using Pythagorean theorem, I needed two sides, and I could find the third side. What's going to happen here is you're only going to get one side. The other thing that you need is an angle. So if you have one side and an angle, you can find a missing side. And then we will be finished with 12.1. Okay. Now, before we get too far into it, there's a couple things that I want to show you. First of all, have a calculator out if you don't have that out already. The first thing I'm going to show you has to do with a couple special triangles. And if you've taken geometry or taken it now, you should have seen these already. If not, this will be new to you. It's on page 1775. These two triangles, a 30-60-90 and a 45-45-90, are important for a couple reasons. I am not going to ask that you memorize this. Okay? You really should memorize these relationships between the sides, though. I'm going to start with the 45-45-90 first of all. Anytime you have any triangle that one of the angles is 90 and the other two are 45, the two legs will have the exact same measure. So the two legs will have the same side, same size, and the same length. The hypotenuse will always be whatever that length is times the square root of 2. Then, of course, you can derive these just by looking at opposite, adjacent, and hypotenuse. What's interesting about this, if you notice that the sine and cosine of 45 are the same thing. And the reason being is that if I look here, the opposite side is x, and the adjacent side is also x. Because the legs are the same length, that's why the cosine and the sine have the same value. Okay? And then opposite over adjacent are going to be those legs divided by each other. So it's important to know this relationship. You can derive those. Up here in a 30-60-90, you've got a 60-degree angle, a 30-degree angle. What the relationship is that the hypotenuse is double the shortest leg, or the shortest leg is half of the hypotenuse. And then the longer leg is going to be that shorter leg times the square root of 3. And then all the associated trig functions that go with it. Okay. Like I said, I'm not going to ask that you memorize these. You should probably know these relationships. More than anything, I want to expose you to this because you're going to see this later on in pre-calc more frequently. Okay. Next thing we need your calculator for. Make sure you're in degree mode. If you're unsure, go ahead and check that real quick.
You gotta go to mode.
These, the sine, cosine, tangent, they all have a value. So make sure you're in degree mode, and literally all you have to do is type this into your calculator. No inverse sine, no arc sine, anything like that. Just sine of 27. If the only time we ever use the inverse or the arc sine is when we're trying to find an angle. What's the 10,000th place? How many places is that?
4.
That is 4. So go ahead and find these three things, and then we'll just make sure you know what you're doing there. Here's what you should have had, okay, for those three values. Nearest 10,000th, that's 4 places. So the sine of 27, 0.4540. Cosine 152, negative 0.8829. Tangent of 243, 1.9626. How many had all three of those correct?
Me.
Okay, good. Now, here's there's a reason we need to know how to do this, but before we do that, I have another video that I kind of like. Some of it is we've seen before when it goes over SOHCAHTOA in a little different way, but the part that I kind of want you to focus on is going to be the part where they talk about finding missing sides. Okay, so I've included a link to the actual video in your assignment, but I've got it screen recorded to play here, so we'll get to see this too. Okay, so pay attention, quiet please.
This girl looks like a real rapper.
Guys, I am so excited because we are finally going to start our unit on trigonometry this morning. Miles,
Is there any way we can make this a bit fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. Just can't sit, gotta get tricky with it. That's it, 3 angles, 3 sides. T-R-I-G, all up in my eye. SOHCAHTOA will tell you where to go. just gotta know about H, A, and O. Everybody looking at a glance at the box. The HYP is sitting across. Theta, theta is after Eta, Eta. So on it, for the look, I don't mark it. Beside you ain't touching is the OPP. Making it tricky, we want you to see. Yo, what's that last side you say? Ha ha. It's gotta be the ADJ. Get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it. What? You wanna solve with a trick? Watch your step, you might fall trying to work this gate. Soak it up, soak it up, soak it, soak it toe up. In the middle of the problem, don't know which one, huh? You gotta know which angles and sides that are missing and living in the problem. They're the guides. You can come with me, all these problems I've tried. Heard it's hard, well then somebody lied. It's soak it toe up, helps you to study, so you know when to use each one. If you got the O and HYP, so let's you know, that's the way to go. Let's say now you got the HYP and the ADJ, then cosine's the way, yes y'all. But there's one more, you got the legs?
That makes it tan.
Getting tricky with it. Getting tricky with it. Getting tricky with it. Getting tricky with it.
Okay, so this part, no, I'm gonna keep playing it. This is the part I really want you to pay attention to. He's gonna talk about finding a missing side, and this is really important, so pay attention.
Roll with me right now. If you need a side, you gotta know two things. Okay, let's ride. You need an angle and one of the sides. Issue is where does X reside? See it up high, that's how you know to multiply.
Okay, so real important. When the X is up top or up high, like he said, you've got to multiply. And notice that he put the number in front, and I'll talk about that more later.
So easy, you get it on your own first try. Trig to the maximum, I'll be axing them. How about the one time you gotta use television? Only if X is down below. X and the angle will switch, you know. Last.
Okay, so actually, let me go back to that. Right.
That was incredible.
So close. Okay, so notice what he did here. So when the X was down below, basically when he was dividing, okay, he switched those. So now instead of multiplying, you're going to divide the number. Whatever the side they give you divided by the sine or cosine or tangent. So when the X is down below, you end up having to divide. When the X is up top, you're going to multiply, okay? So that's the gist of the video. All right, so let's look at an example. If you want to watch the whole video later, you're welcome to. All right, so go ahead and get that in there, in your notes, and then we'll talk about what we need to do to set this up and solve it. First thing we've got to identify is our angle and figure out our perspective, right? What sides are involved here with respect to this angle? Yeah.
The
hypotenuse. Hypotenuse and
the
adjacent. So what you're going to want to do, you're going to want to identify the sides that are in play, and that will help you decide which function you're supposed to use. Okay, so which function are we supposed to use here? Cosine. Okay, so my setup is pretty simple. The cosine of the angle, 39 degrees, equals the adjacent over the hypotenuse. Okay. Now, we could, like we just did on the other page, we could type this in our calculator first, but I'm going to hold back on that. I'm going to recommend that you don't do that. The cosine of 39 equals x over 7. Am I going to multiply here to find x, or am I going to divide? Multiply, because the x is up high. So, now, notice here, this is really important. I put the 7 in front. And what that allows me to do is type this in the calculator just as it is. If you put the cosine first, then you're going to have to make sure the whole thing is in parentheses and then multiply by 7. Okay? If you put it in front of the trig function, you're not going to have to worry about parentheses. You're not going to have to worry about the calculator taking the cosine of some other number if you just put the number in front. Okay? So go ahead and type that in just as is. Round to the nearest tenth. Round to the nearest tenth and see what you get for your answer. So J. Henry asked a good question. Do you have to put units down? What do you think?
Yeah.
Yeah, we're looking for a length of a side. It has a measure. In this case, we don't know what the measure is, so we write units. So you should have 5.4 units. How many got that?
Yeah.
Okay, good. Take a look at this one. Try to set this one up yourself. Don't solve it yet. Just do the setup for now, so we can see if you've got it right. Okay. So let's take a look and make sure that we've got it set up correctly. Our angle is 46. So which sides are at play here?
Opposite and hypotenuse.
Opposite and hypotenuse. So it's going to be sine. So what you should have set up is sine of 46 equals 8 over x. How many had that? Okay. So when we get to the quiz on Friday, make sure you write this down. Okay. Now, since the x is down below, I'm going to swap these and essentially divide. Okay. All right. So I swap those two out, and so 8 divided by sine of 46. All right. What do you get?
11.1 units.
11.1 units is correct. How many had that? Okay. Good. One more.
Me.
Do this one. So again, we're looking at 27. The sides that are in play are opposite and adjacent, which means we're using tangent. Okay. Tangent 27 is x over 10. X is up high, so we multiply. Again, put the 10 in front. Okay. And you should get 5.1 units. How many had that one correct? Okay.
I got about